So this week, today in particular, we'll continue with DNS. Last week we did the basics, a forward lookup, and you did the lab report already on it. So the next thing this morning is to work on reverse lookup. There's actually a lab report question there in my lecture notes. And now we're dealing with reverse lookup. And then after that, we'll do master slave and forwarder. So we'll see how far we can go today. If we don't finish it all today, we can finish it tomorrow. We'll see how it goes. But tomorrow we'll definitely have time to at least do part of something else as well. So reverse lookup. I don't have a lot of lecture notes here, but I'll explain the idea and show everything. So please take good notes. So reverse lookup is the opposite of forward lookup, meaning as defined here, to resolve an IP to a host name. So forward lookup that we did last week is more straightforward, right? And that's the main point of DNS. Forward lookup is when you have a name and you want to know the IP. So it resolves the host name to an IP. So most of the time, that's what we think about when dealing with DNS, forward lookup, resolving a host name to an IP. But now we're dealing with the opposite here, which is knowing the IP. You're asking what is the host name. So it's less intuitive, right? You might say, how can that be that someone knows an IP and then looks for the name? Well, yes, this is less obvious than forward lookup, but it's part of DNS, and it is definitely useful in many scenarios. Example, some security software require this, because if someone makes a connection by IP and the system is not able to resolve it to a name, to a host name, then it could be that there is a security issue there. Maybe whoever is trying to connect is a hacker, trying to hide the host name or doesn't have a valid host name. So that's why for complete DNS configuration, we're also supposed to know how to deal with reverse lookup, knowing the IP to find out the name. And as written here, reverse lookup is based on PTR records. It's a special type of record. Just as we have seen last week, we have SOA, NS, A records, CNAME records. Those are used in forward lookup. In reverse lookup, we also use SOA and NS, but PTR is a type of record that resolves an IP to a host name. So it's like the reciprocal of an A record. An A record, a host record, resolves the host name to an IP, while that's in forward lookup, while the PTR record reverse lookup does the opposite work of resolving an IP to a host name. So this is the background information. I hope you see it. Now we move into the practice, and I will show how to achieve this reverse lookup. So any questions on the basic concept? Guys, I have no information that there was a problem last week with the RDP or whatever. You had plenty of time. You had 2 days, Saturday, Sunday. Nobody up to this point ever brought it to my attention there was any problem with the RDP or anything like that. So right now we're doing this lecture. It is not time to discuss RDP, but as it is now, I don't see a reason to extend the lab submission time.
Excuse me, sir.
Just write your messages here.
Yeah, okay.
See, nothing was brought to my attention. I was not, up to this point, I was not aware that there was any problem with the RDP last week. And in my opinion, you had enough time the whole weekend last week to do this lab report. So for now, we're focusing on this lecture. We don't have time to do this discussion. You have to use your time efficiently, guys. You have to follow the lecture well, take notes, and then immediately after the lecture, we have 2 days to work on the lab report. Okay, so. All right. So now we're dealing with reverse lookups then. So I'll go to my server. You see, now it's really time to focus on a lecture. If right now your concern is the last week's lab report there, and you don't follow the lecture, it's going to make things only worse for you, because then you're going to fall behind for this new material. All right, so I'll go on the DNS server. I just started this machine earlier this morning, so I'll do the basics, turning off the firewall and then starting the service. All right. So I'll start with name.conf. I'm on the DNS server again. And here is an example of reverse lookup zone. This is what it looks like. So in name.conf, this is what you'll need to type. So it's a new zone, and for reverse lookup, this is the syntax to be used. For the zone name, you put the net ID backwards. You see, reverse lookup is to resolve an IP to a host name, right? So you put the net ID backwards. So the net ID I'm using is 192.168.100, right? So here I put 100.168.192. So that's what this is really required. The zone name has to be like this. You cannot type arbitrarily any kind of name. It has to be the network ID backwards and then .in-addr.arpa. This is a syntax in addr.arpa that comes from the earlier days of the internet. Many, many years ago, when the internet was still starting technology, it was called ARPANET. So that's where it comes from. Okay? This is not a Linux-specific syntax. In Windows, when you create a reverse lookup zone, it is also called this way. The difference is that there you have a more user-friendly wizard, and then the wizard creates this syntax for you. Maybe you have noticed in Windows DNS, when you create a reverse lookup zone, at the bottom of the screen, you will see this syntax in the wizard. All right, so the rest is familiar. Type master, and then for a file name, I'm using this convention, named d dot, the net ID. So here, no problem, you can type the ID in the regular, not backwards, but in the regular sequence, 192.168.100. And of course, you have to close the bracket. Let me highlight the whole thing. So look at this if you have any questions on how to declare a reverse lookup zone in named.conf. As usual, syntax is critical. Everything has to be typed properly. So this also means in var named, you'll need to create a file named.192.168.100 or whatever is your network ID. And that's what we'll be looking at next. All right, so we seem to be okay with this, no questions? Next, I'll go to var named. And this is where I have added the file named.192.168.100. And you have a template of this in the class share. I'll show that afterwards. Maybe you've already downloaded the template. So nano so the starting points are similar. SOA, the host name of the server, and hostmaster. See, I put soccer.net here. You may put actually any of the forward lookup zones which use this network ID. I could have put linkzorp.com or sports.com. I just put soccer.net here, which is one of my forward lookup zones. You see, I'll show it here. I have a forward lookup zone named named.soccer.net, in which I have hosts that result to the IP in this range 192.168.100. So for the host master again, any of those zones would be okay. Soccer.net, sports.com, linkzorp.com. Okay. The SOA is, as usual, the host name of the server. Now, when you type the NS record here, unlike forward lookup zones, you have to type the complete FQDN, not only store, because since this reverse lookup zone is IP-based, it does not limit itself to only one forward lookup zone. So you cannot simply assume that by typing store, it will know what to append it with. So you type a complete FQDN like this one, your store.soccer.net. And then here are examples of PTR records. So, see, for store.soccer.net, the way it's in CentOS 7 this is the way it works. For every PTR record, you have to type a pair of lines. Like this, the two lines together are used to create one PTR record. Because in the first line, you type the complete info about the host record, store.soccer.net in A, and this is the IP it resolves to. And then on the next line, you put the host ID, 28 in this case, in PTR, and then the FQDN. You know, to make this clear, what I'll do, in the second terminal, I'll open the soccer.net forward lookup zone. And then you'll see better what's going on. So here I have namely.soccer.net. So you see I have the host record here, a record store that resolves to 28. So before you can create a PTR record, there must be a corresponding host record in a forward lookup zone. You cannot just like that create a PTR record out of nothing. First, the host record must exist, and then you provide the corresponding PTR record in reverse lookup. So here is the host record now, for which I'm creating a reverse lookup PTR record. So what I do in reverse lookup zone, I type this information, see store.soccer.net, and the corresponding IP in A. So that's basically duplicating the host record information here. And then on the next line, you put the net ID of this IP, which is 28, in PTR and the FQDN store.soccer.net. So it makes sense. Look at it if you have any questions. So now let's look at the next line here, next example. This is about store.linksdrop.com. Now, you see a single reverse lookup zone may include records for hosts which are in different for lookup zones, because what defines the reverse lookup zone is the IP. So now we have something about linksdrop.com here. So I'll open the linksdrop.com forward lookup zone here. So this is linksdrop.com, and you see for 28 I have this record in A 28 store. So this is store.linksdrop.com. So what I provide here is store.linksdrop.com in A28, the complete IP. On the next line again, I put the host ID 28 in PTR store.linksdrop.com. Let's look at the last example here. I have volley.sports.com. So it's now sports.com. So I'll go to sports.com. So in the sports.com zone, I have the record volley that results to 99. You see, what all these things have in common is the net ID, 192.168.100, and that's why they can all make use of the same reverse lookup zone. So this is volley with the host ID 99. So volley.sports.com. So now in the reverse lookup zone, I have put volley.sports.com in A with the IP 99. And next line, I put the host ID 99 in PTR volley.sports.com. It's very simple, just to understand how it works there. So again, any questions on this? How to create reverse lookup records? So there are no questions. Let me ask you a question there. You see, I'll exit this now, this file. So in my var named, so I have only one reverse lookup zone. And same thing in named.conf. Now, is this always enough, or when would I need to create a second reverse lookup zone? You say I have many forward lookup zones, linksdrop.com, soccer.net, force.com, college.org, nature.org. All these are forward lookup zones. but I have only one reverse lookup zone. Can you think of a scenario where I might need to create a second reverse lookup zone? When would that be needed? Think about it. I'll wait for an answer there. All right. When need to resolve different net ID, very good. Both answers are right. So that's exactly the point. Reverse lookup zone is related to the net ID. So if this is the only net ID I'm using in my DNS at this time, is all I need. This reverse lookup zone takes care of any IPs which are in this net ID. But if I also deal with other net IDs, such as 192.168.200 or any other network IDs, so if my DNS server also needs to service other network IDs there, then for reverse lookup, I will need to create more files, such as named.192.168.200. And then I will also need to go back to named.conf. So let's show that again, and declare also the zone there. So if I go back to named.conf, you see, this is the only reverse lookup zone I've declared at this point. But if I do need other network IDs, then I will create a second zone here, similar syntax, but I will duplicate it, and I'll put, for example, 200.168.192, and then namely.192.168.200. So that will be a reverse lookup zone for another network ID. And then I'll go back to var named and create a corresponding file. So you create as many reverse lookup zones as the number of net IDs that you deal with. The more net IDs you're trying to service, the more reverse lookup zones you will need to create. So now let's check this. How do we verify the reverse lookup is working from a client machine? I'll start with the Linux client, this one here. And I just booted up this machine this morning, so first check that I can ping the server. Because I keep on saying this, and don't think that I'm just pointing to this class in particular. I teach to our class as well, and I always say these things because I see week after week, day after day, I see students who waste time because they don't check the basics. You see, I always start with this. I never take it for granted that things are working properly. Because if I cannot ping the server, then there's no point trying anything else. First, I have to deal with this. I have to troubleshoot why I cannot ping it. So I feel sorry when I see students who waste an hour or 2 hours in the lab time trying to troubleshoot what was wrong with DNS, what's wrong with this or that, but he or she never checked the basics. Ping wasn't working in the first place. Okay? So now, to check reverse lookup, do the same nslookup command. So you put nslookup and you put the IP. So what was the last example? It was 99, right? Let's open it again. See, if I put this one, the last example, so you put nslookup followed by the IP, and then it should give you the name. Here we go, it gives volidasports.com. This is exactly what reverse lookup is saying. That 99 corresponds to volidasports.com. Now, here I have two IPs, right? I have one IP for two names, and that's perfectly okay. I have store.soccer.net and store.linksor.com in two different for lookup zones, they both result to 28. So if I do NS lookup in the client for the IP, 28, you see it gives both. And it's perfectly all right. You can have two host names that result to the same IP. And it we'll see later also in module 3. You can make use of this, for example, to create two websites on a server that run on the same IP. That will work. One website will be www.soccer.net, the other will be www.linksorg.com. And they can share the same IP. So this is how to check reverse lookup. NS lookup followed by the IP. The host command also works. Instead of NS lookup, you can put host followed by the IP. But the host command works only in Linux. In Windows, use NS lookup. So speaking of Windows, let's check that too. So first I'll point to write DNS server. I'll make sure because I've been using this machine in a different course as well. So my DNS server is 27. So again, first I'll make sure I can ping it. All right, and now I'll do an NS lookup. So that's one example. It's getvoted.sports.com. Now, in Windows, when you do it for an IP which has two names, it gives only one of them. It picks one of them. But it doesn't mean that the other one doesn't work. You see, it's just that on the Windows client, it shows only one of them. If you do it a second time, yeah, again, it picks linksorg.com. But you see, when you do the same thing in Linux, it shows both of them, linksorg.com and soccer.net. All right, so time to see if you have any questions on reverse lookup, either on how to create it or how to check it. So for you to do this in the lab, you have a template again. You may have noticed it. So in the class share, it's in the DNS folder, and a template file is right here, namely .192.168.100. So it's similar to my examples there, but it's only one record shown here. It's a very simple, straightforward example. So you get this file into your DNS server, and then adjust it, edit it to meet with your specific requirements, what names and what IPs you're using. But a template gives you the basics that you need. Okay, so no questions, we're okay? I'll wait just a few moments. If you don't have any questions, I'll reverse lookup and move on to the next subject, which is master-slave configuration. All right, so time to start master-slave. And we'll start with some explanations there. Now, at this point, you'll need two DNS servers. I think I did mention last time, right? I said if you have time, install a second DNS server. If you haven't done it yet, that's one of the first things. I mean, once you finish reverse lookup, or maybe before that to save time, you need a second DNS server. So you may use one of your existing servers, or if you don't have one, you should install an CentOS server. And just basically copy the namely.conf file there, and you'll see now how to do for the rest, how to set up master slave. So starting with the explanations, master slave. Yeah, here I have only put the title, but probably you've seen this concept in Windows as well. I mean, you've done it in Windows. So I have a diagram to explain this. Sorry. Now, in Windows, this is referred to as primary secondary, but in Linux, it's referred to as master slave. Same thing, it's just a jargon. So in order to avoid any confusion, I'll change it here. Instead of primary, I'll tap master. Instead of secondary, actually it's uppercase, right? So I'll keep it uppercase. So instead of secondary, I'll tap slave. And then the forwarder will do it later, so let's not worry about forwarder now. So now I'm focusing on master slave, which is, I repeat, the same thing as primary, secondary in Windows. So here I put, instead of Windows 7, I'll put CentOS 7 there, or simply CentOS for the client. And the IPs could be different, it doesn't matter. So what's master-slave? We have two servers. The first one is defined as a master, the second one is defined as a slave, and this is really on a per zone basis. There is no such a thing as a master server in general or slave server in general. For a given zone, such as sports.com, server 1 here will be defined as a master, and server 2 will be defined as a slave. So I repeat, it's on a per zone basis. So now what is the point then? The master server is the server on which you initially create the zone, and also that's where you may subsequently edit the zone. So that's why it's called master. I repeat that. This is the server on which you create the zone initially, and if later you want to make any changes to it, you do it on the master. The slave server, on the other hand, initially you don't even create the file there. You only declare it in md.conf. But in var.md, you do not manually create a file for this zone, because the slave server will get the zone, the file from the master. It will download it from the master. So it's referred to as a zone transfer. So the file, the zone file in var.md, is created initially only on the master. And then through configuration that we'll see, it will be transferred to the slave as a read-only copy. So the slave will simply get from the master a read-only copy of the zone file in var.md. All right? And then if there are any updates, again, it will be done on the master, and then it will be updated to the slave through subsequent zone transfers. So the slave server simply makes use of the file which is created and updated on a server, on the master. Do you see the idea? Any questions? Now, what's the objective of this? I've written it here in summary. See, it has two main objectives, which are redundancy and load balancing. Let's explain. What does redundancy mean? You may also call it fault tolerance or backup. Or also it's called resiliency. So the idea is that when you have two servers that have the same zone, so the slave has a copy of the master zone, then you get this redundancy, because if one server crashes, becomes unavailable, if, for example, something happens on one day and a master server becomes unavailable. Now, here we have a backup because the slave server has the same zone, a copy of the same zone, and therefore you can quickly reconfigure clients to point, all of them to point to the slave server, and they will get the host name to IP resolution they need. So this way, you avoid interruptions in your network. You don't depend on one server always being up and running. If you have two or even many servers acting as master slave there for a given zone, because you may have multiple slaves as well if necessary, then clients are protected. If one server fails, then there's another one that has the same zone, same formation. Okay, so that's one reason why this is interesting. And the second reason is load balancing. This means even if nothing goes wrong, even if servers don't crash, let's say, you still benefit from this because the master and slave will share the load and things will go faster. So especially in a large network where you have lots of clients, you may configure some clients to point to the master at their DNS servers. Other clients may point to the slave. It could be part of the overall network design, depending on departments, company branches, and so on. And because otherwise, for sports.com, all of them would point to the master, right? If there was no slave. And that would create lots of traffic on the master. And things will get slower and slower. But having master and slave separately, and some clients pointing to the slave, some pointing to the master, then you get a more balanced operation, and things will go faster. Because the master will have only, let's say, half the clients to service, and the other half will be serviced by the slave. So that's the explanation of what it is all about. Any questions on it? Again, if you remember it from Windows there, this is the exact same thing as primary, secondary, and Windows. It's called master-slave. And in fact, it's 100% compatible. You may set up a Windows DNS server in this network, and then the master could be CentOS, and then the secondary could be Windows, or the other way around. On Windows, you may have a primary zone, and CentOS server may act as a slave for it. It's the same protocol, same port number, port 53 for DNS. So no questions for now? We'll see how to set up for this to work. So for master-slave to work, you'll need configuration both on the master and on the slave. So I'll start with the master. So here's again my main DNS server, the one I've been using so far. It's uppercase, I think. It's the other way around. Right. So we start with named.conf. So I'll use the example, a zone named soccer.net. It's already configured for me here. So I repeat, I am on the master server right now. And zone soccer.net. So the first few lines are, it's nothing new. Type master. So now we are saying the meaning of type master because I'm on a master server here. And the file named.soccer.net. But I have added a line here, which is allow-transfer. And watch the syntax, space, bracket, space, then the IP of the slave server. Then semicolon, space, you close the bracket, semicolon. And of course you close the overall bracket there. So basically this line allow transfer is to authorize the zone transfer from the master to this slave server in particular. So of course it assumes that the machine 192.168.102 is also a DNS server. It has the bind package and it has the appropriate named.conf file. You cannot just pick any machine just like that and put the IP there, hoping that it will become slave. It has to be a DNS server. which will act as a slave for this zone. So that's all you need to do on the master as configuration. Then we'll look at a slave. But first, any questions on the master? Of course, don't forget every time you make a change, you have to restart the service, right? Also worth mentioning here, if you go online and do some readings about this or check the man page, there's also another line which is allow-update. So don't get confused between those two. What you need to use here is allow transfer, not allow update. Allow update is for something else. So for master slave, this is the syntax, allow-transfer. Don't type allow update there. So let's look at the slave now. So I'll go to my second DNS server. So this one also is set up as DNS server. It has a bind package and a copy of named.conf. So I'll go to named.conf. I'm in etc already. In the internal section, here we go. You see I've put zone soccer.net. So the zone name is the same. So the first line is just regular zone declaration. But then, starting on the second line, we see differences. Here is type slave. And then file slaves hyphen namely.soccer.net. I'll explain in a moment why. For now, take note of the syntax. So you put slaves slash named.soccer.net. So compared to the master, maybe I should show both at the same time. Here is the master server. So zonesoccer.net. On the slave, you have the same thing, zonesoccer.net. Then on the master, you have type master. On the slave, type slave. On the master, you have file named.soccer.net. On the slave, you have file slaves slash named.soccer.net. This will be clear in a moment why. Then on the master, you have allow transfer with the IP of the slave. This is the IP of the second DNS server, .2. On the slave, you put the mirror image. You put masters and the IP of the master. So basically, on the master server, with this line, you authorize transfer to the slave. And on the slave, you put this line so that the slave will know where to get the transfer from. So it needs to know the IP of the master. It's very simple. Very logical. Just make sure your syntax is 100% okay. So any questions on this? No, everything is clear? All right, so that's the naming.conf configuration on the slave. So now let's continue. How do we verify? How does it work in the end? So now I'm focusing on a slave server here. And I'll go to var named. At the same time, I'll show the var named of the master. I'm in var named. So on the master server here in var named, let's clear the screen. This is the master server. And as usual, I have the file named.socker.net. It's right here. So that's where the file was initially created on the master. named.socker.net. Now, when I go on the slave, I do ls, I do not have a file called named.socker.net here. But wait a second. What did we put earlier? In named.conf here, nano, etc named.conf. We said the file name expected to be slaves slash named.socker.net slave. So now let's see why. Because the way it's organized in CentOS 7 is that under var named, you have a subdirectory named slaves. So that's where you're supposed to have your slave zones. So this makes it sure that things are more neat. We don't mix master zones with slave zones. So master zones are supposed to be saved directly under var named, while slave files should be in the subdirectory slaves. But even when I go there, I'll go to the subdirectory slaves. So now I am in var named slaves. You see, at this time it's empty. I don't have the file named.socker.net yet. And I should not create it manually myself. If you do that, it won't be slave zone. You don't create here the zone file. The whole point is that it should be a zone transfer coming from the master. So when is that going to happen? Very simple answer. When you restart the named service on the slave server. As you finish configuring your named.conf, you save it, and as you restart the named service, it should right away contact the master server and download the file from it. Since the master is authorizing it, allow transfer. Just let's make sure again that I can ping the master, or else nothing will work. Right, I can ping it. So I'll just restart my named service. Remember, the directory is empty right now. Let's clear the screen. So I am in var named slaves, and it's an empty directory right now. By named.conf, I did my configuration to say I want slave zone, the master being this server with the IP 27. So I just restarted my named service here. Is it running right now? Let me check. It's not running, so If it's not running, just start it. If it was running, I would restart it. So system control, start, named. It will then update everything by checking named.conf. And now if I do ls again, here we go. I got the file. It just received the file as a download from the master. And to see more details, I'll do ls-l. See, it just happened at 9:28 on June 5th. Looks like my virtual machine is 1 minute ahead of my physical machine. We can forgive that. And very important detail here, who's the owner of this file? Look at this. It's not root. I'm logged in as root, but root is not the owner. And no surprise there because I did not create the file myself. I did not perform download myself. I just restarted the service. And the owner is an account called named. Who is this? It is the system account, the internal account of the DNS service. This is the account that made the zone transfer happen when I restarted the service. So it is the owner of the slave zone, of the slave file. You check the password file, I'll show you in a moment actually, you'll see this account there is an internal account. So now it's complete, it's done. Transfer has just happened. Any questions? Are we all following? Because I don't see any questions there. Is everything clear? So again, this is a read-only file. Don't attempt to edit the file on the slave. Not only it will not work, you may even end up corrupting it. You're not supposed to edit the file on the slave. You edit the file only on the master. I'm talking about named.circuit.net file. So you edit the file only on the master. Here, nano named.circuit.net. This is where you create and eventually edit the file. On the slave, you just get a copy of the file, you don't touch it. All right? So now how is this going to help? How do we use this? So to show that, I'll first go back to my diagram. You see, I'll be using two clients. One client that points to the master server for DNS, and a second client that points to the slave server for DNS. So my CentOS client will point to the master. Here's my CentOS client. So I'll double check that, nano etc.resolve.com. So it points to 27, which is my master server. So in my diagram, I'll update the IP here. It's 100.27. and instead of sports.com, I'm using soccer.net. And the IP of my slave is 100.2. All right, so now my CentOS client points to the master. My Windows 10 client, I'll make it point to the slave. So 100.2. I can ping it, of course. I'll double check. I can ping the slave. Yeah. Also on Windows here, I clear the cache because Windows clients tend to cache the DNS information more often than Linux clients. So just to make sure that I don't get any previous information, now that I'm pointing a different DNS server, I'll clear the cache. So I'll do ipconfig / DNS. So I'm starting from fresh now. Okay. So now to check if everything is working properly, let's see what records we have for this zone. Back to the master server. In soccer.net, I have here store. There is also 28. And there's an alias for it, which is, let's check. So I have an SMTP alias for store. So SMTP dot soccer.net should resolve to 28. Okay, so let's verify that. On the CentOS client that points to the master, I'll do ns lookup smtp.soccer.net. So here we go, it gives 28. So it's coming directly from the master server. Now my Windows client points to the slave. So I'll do it here, ns lookup smtp.soccer.net. You see it's pointing to slave's IP 100.2, and I get the same result, 100.28. This one is getting it from the copied file, the zone transfer file on the slave. But the same info. So here is an example of load balancing. We have two servers that have a common zone file, master slave. So some clients point to the master, some clients point to the slave, and they get the same information. So there'll be less traffic on the master. Some of the traffic is being absorbed by the slave. Any questions? let's continue with this. What I'll do next, I'll go to the master server and make a change. Here's the master server. So for the same alias there, you see SMTP. I'll call it something instead of SMTP. I'll call it, just to make a difference there, I'll call it SSL. So now the alias name has changed from SMTP to SSL. So I'll save this on the master. And of course, I'll restart my named service here. So close named.conf file before restarting the service. So system control, restart, named. So now let's go, we have now those two clients. The first client is pointing to the master. If I repeat the previous lookup command here, it no longer works because the alias name has changed. It is no longer SMTP, it's SSL now. So if I do lookup SSL instead of SMTP, it works. So it's clear that on a client that points to the master, the change has happened. Now the new alias name is SSL. SMTP no longer works. Now what about the other client, the Windows client that points to the slave? So here, if I repeat SMTP, it still works. If I try SSL, it doesn't work. So what's going on now? Even if I clear the cache, you might think it might be a caching problem. Let's clear the cache again and try again. So SSL doesn't work. But SMTP works. So this is the older information. Does it make sense? Yes, absolutely. Because this client is getting it from the slave server. I did the update on the master to change on the master, and I didn't update the slave yet. The slave still using the older copy in which the alias name was SMTP. The slave is not aware yet that a change has happened on the master. So what's the solution then? Obviously, it is to update the slave. How do I update the slave? If you want an immediate update there, something very simple to do. Just go on the slave, in the location where the slave zone is located, here, just delete the file and then restart named service so it gets a new download from the master server. So I'll delete this file. So the slave directory is empty again. And I'll just restart my named service. and I just got a fresh copy, a fresh zone transfer file master. So this now should be up to date with the new alias name. So back to the Windows client. Again, I'll clear the cache to make sure. And now if I do SMTP, which is the older alias, it no longer works. If I do SSL, which is the new alias, it works. So now the slave is up to date with the master. So I'll pause a bit here. Let me know if you have any questions. Yes, the restart namely service, you're right. That's exactly what I did to give the slave server a chance to get a new download. But first delete the file though. Delete the file before you start a service. That's what I did, right? If you don't delete the file, it may not work. Because the file is still there, it may not overwrite it. Now, in my lecture notes, I have just the titles here. So, but now here we go, script to update slave. Because what I just did here, of course, it works. But let's say you're in a very dynamic environment and you often make updates to the master. It may not be the case. Maybe you set up the DNS server, the master zone. It might be that for the next 6 months you won't need to make any updates. But it could also be that it's a more dynamic network in which IPs and names change often, and you might need to update the master often. In that case, it might be a bit annoying or tedious to all the time go and manually, do this process of deleting the existing file on the slave and then restarting namely service. So that's exactly where scripts can be very nice, right? So we may create a script on the slave server to take care of this update, so that whenever you run the script, it will make sure that the slave server will be up to date with the master. So I have it there, and I'll show it. See, script is nothing more than automating the process. So if you know how the process works, you have done it manually, then you can put it in the script. Also, I'd like to make it clear that this the idea of restarting the namely service is only on the slave. You don't need to restart it on the master. It is the slave that needs to be updated, and that's where you restart namely service. Of course, when you make the change on the master, of course, on the master too, you need to restart the service for the change to become effective. I'm talking about when it comes to update the slave. To update the slave, you don't need to restart the service on the master. You need to restart it on the slave. All right, so now let's show the script. I'm on a slave server here. And I'll go to Usually I save my administrative scripts in /root/bin. That's a very good place to save them. Scripts which are only for root. And I've created here script called SL update for slave update. How do you create a script again? You just initially create a text file in which you type your commands, and then you give it execute permissions. You see ls-l. Root has the execute permission. So I'll give him permission, chmod permission 700 for it. And you save it in a directory which is part of the path for root, and it is already there, /root/bin. It's part of the path for the root user. Now, what's the counter of a script? So only 2 lines. So I'm first forcefully deleting the slave file. So var name slaves, the zone file there. Why do I put -f? Because otherwise it may ask to confirm, right? Yes, no, you want to delete it. When you run a script, you want to make it as automatic as possible. So you won't need to type yes to be around there and type yes for it to work. And then just restart to name this service. Any questions on this one? So to finish it then, this part of the lecture is close to break time. Now that I've shown the script here, I'll do another example of updating the master, changing the file of the master there, editing the file of the master. And then this time I'll use a script to update the slave. So I'll go to the master server. And I'll go to var named. Actually, I have it on the other terminal here. So I'll edit the file again, and I'll put it back to SMTP. I changed it to SSL earlier. I'll put it back to SMTP. So for this change to become effective on the master, I will restart the service. And it should right away be verified now on the client that points to the master, which is right here. So now SSL will no longer work, but SMTP should work again. Here we go. Now on the Windows client, which is pointing to the slave, on Windows I always prefer, when I have fast changes like this, to clear the cache to make sure nothing is coming from older information. So now SMTP still will not work because this is still SSL now. This is what the slave server has at this time. SSL works, SMTP doesn't. So I need to update the slave. So for this now, I'll go to slave and I'll just run the script. So SL update. So this will delete the existing slave file and restart a service in order to get a new zone transfer. And now back to the Windows client. Another cache clearing. So now SSL should no longer work and SMTP should work. So SSL no longer works, but if I try SMTP, it works, so the slave is up to date. So this completes the demonstration explanations for master slave. Before we take a break, again, if you have any questions, it's a good time to ask. And also, I'd like again to bring up the idea that this master slave setup is on a per zone basis. See, right now, this is my slave server. But I may, if I wish, on this server create a master zone and make the other server slave for it. It's just a question of declaring the appropriate info in the respective name.conf files. So there's no such thing as saying that this server is always a slave, the other one is always a master. It depends. For a given zone, one might be the master, the other might be slave. For another zone, it might be the other way around. And you may also do master slave for reverse lookup zone. It works the same way. So no questions on master slave. You may also ask questions if you have any on what I did earlier this morning, which was reverse lookup. After the break, I'll move on to the next subject, which is forwarder for DNS. So here's my diagram again for master slave. I'll use the same diagram as a break for forwarder. That's why I also have forwarder here. One more thing, since you're not asking any questions, I can provide additional explanation here. So it's possible to have multiple slaves for a given master. And that's why when I go back to on the master server, there are revisit name.conf file. See, when I put allow transfer, the syntax here, after semicolon, I may leave space. Sorry, after semicolon, and I may put another IP, let's say 192. This numlock thing kills me. So space, let's say 100.5, assuming that 100.5 is an RDNS server which will act also has a slave for his zone. So now I am authorizing the zone transfer to two slave servers. This could be useful in a larger network where it will be justified to have multiple slaves for one master. All right, so if there are no questions there, we'll take a break and I'll be back as usual at 10:15. So be on time, at 10:15, the lecture will resume.